All right, welcome to the second half of our Chapter 3 content. This time we're going to talk specifically about the designs we can employ in this approach. Okay, first up is the simple A-B design, which has two phases. A is the baseline, and B is the treatment. So A, the baseline recording before we have any sort of behavioral intervention, and then B being the treatment phase where we manipulate something, we add our IV, and we measure the outcome. So this does not demonstrate a functional relationship, right? There's no replication, and it doesn't do much to rule out the possibility of an extraneous variable. Though, I mean, this is still used, right? It has a place in clinical practice or self-management projects in a situation in which we're not terribly concerned about demonstrating a functional relationship. We just, are more interested in the product. Next up is the AB-AB reversal design. This is, I think, pretty self-explanatory. It has four phases. A is baseline, B is treatment. This does demonstrate a functional relationship because it allows us to control for some of the things that we couldn't with an A-B design and allows us to replicate. So there are variations on this, right? If, for example, we're trying out more than one treatment, it might be an ABC-AC design, right? We might do A, B, and then try C, and then go back to our reversal, go back to our baseline condition, and then try C again. There's other ways that you can do that as well. So some considerations for using the AB-AB renewal design is, one, is it ethical to remove treatment? If someone's having a really bad time for whatever reason and we demonstrate some improvement with a treatment, is it really a good thing to remove that treatment from that individual just to establish that we've found something causal here? I think that depends on the situation, right? But it's just a consideration to keep in mind. Sort of like that is, can the treatment be removed? In some situations, the treatment that is imposed may be very long-lasting or permanent and might not be something that we can actually remove easily. Or will the level of behavior reverse? Under some circumstances, we might not expect the behavior to return back to a baseline. Okay, so let's take a look at this example from your textbook. So we have a student that is showing a number of aggressive responses that we would like to reduce. Here we have the sessions mapped out over time. And our phases are situations in which the teachers are making demands of Bob, the student, asking the Bob to do things, or a situation where there are no demands. We can see here plotted that the number of aggressive responses is high with demands, and it drops down to being low with no demands. It returns when demands are made once again, and then reverts when no demands are made. So this AB-AB design allows us to demonstrate a functional relationship. Okay, next up is multiple baseline designs, which is what it sounds like. There's at least three types of multiple baseline designs that we're going to talk about. So we're going to talk about the three that are highlighted in your chapter. So the first is when we have the same baseline and treatment phases for multiple subjects. So we have multiple subjects which we're looking at the same baseline and treatment for. So multiple people across time doing the same thing. Next is when we have the baseline and treatment phase for multiple behaviors of the same subjects. We have one person with multiple behaviors that we're trying to alter and treatments for those. So we're tracking baselines and changes for multiple behaviors within one individual. The last one is looking across different settings. So baseline and treatment phases in two or more settings in which the same behavior of the same subject is measured. So in this instance, we're looking at the same behavior and the same treatment, but we're going to look across settings to see if it varies across settings. Okay, so first up, let's look a little bit closer at multiple baseline across subjects. This is when we have two or more subjects with the same target behavior. So in the example we're going to be looking at over here, we have nurses who are engaging in contact situations, which is defined in more detail in the book, basically situations where they should be wearing gloves. So the percentage of the situations in which they are wearing gloves. And we have an intervention. So out of the way here, we have an intervention where we can see the baseline compared to this intervention. Does that increase the percentage of the time where they're wearing gloves where they should be wearing gloves? So the treatment can be staggered over time across subjects. So we see here that the baseline phase ends at different times for different subjects. And the nice thing about this is if the behavior changes for each subject only after the treatment starts, that's evidence that the treatment, rather than some extraneous variable, caused the behavior change, right? So we have multiple people with different situations at different time points experiencing the same intervention, and if they're showing the same change in behavior, that speaks to a likely comment. Right, because it's unlikely that an extraneous variable would happen to occur at exactly the same time that the treatment started for each of the 4 subjects, because the treatment is starting at different times, right? So it's unlikely that something extraneous is happening at these different times. All right, next up, we're talking about multiple baseline across behaviors. So that's what it sounds like. We can look at this graph over here. For a little example of that, we're looking at 2 or more behaviors within the same subject, with that treatment staggered across behavior. So here we have a number of different social dimensions, and the treatment is going to be a social intervention that is tailored at that specific behavior. So here we have a number of controversial questions that are asked, a number of speech acknowledgments or reinforcers, seconds of eye contact, and a subjective rating of affect. We can see here that the treatment happens at different times, right? So we have our baseline period with a treatment implemented, you can see by the dotted lines separating the phases. It's implemented later here for this particular behavior, even later here for this behavior, and later here for this behavior. So again, we have 2 or more behaviors of the same subject where an intervention can differentially impact those at different times. So the strength of this is if we can see the behaviors change only after treatment, then treatment, rather than some extraneous variable, is likely responsible for the behavior change, right? Because it's happening across time. Okay, finally, we're talking about the multiple baseline across settings, which is what it sounds like. The 2 baselines come from 2 different settings where we're looking at a behavior. 2 or more settings with the same target behavior of the same subject, so same person in both places, same target behavior. The treatment is staggered across those 2 settings. Okay, so with this study, we're looking at disruptive behavior of an adolescent in a classroom as a function of having revised curriculum, right? So we have percentage of intervals, so it's an interval measuring technique where the time in class is divided up into chunks, and here we have represented the percentage of those time chunks where disruptive behavior is observed. So this is our baseline period for both the PM and AM classes, and then we can see, following the dotted line, the implementation of a revised curriculum. So we can see here, the baseline decreases with the revised curriculum, and then later, when the same revised curriculum is implemented for the AM classes, we see a similar shift. So this is useful if we think that, the settings are going to be a major factor, right? You can imagine interventions for things like, attentional problems, looking at both at home and at school. Or in this instance here, looking at AM and PM for this revised curriculum, right? Because it could be any number of factors, right? Perhaps they're just better in the evenings, or they have a different instructor during that time. By in sort of putting this revised curriculum in staggered across time and doing it with these different time settings, or multiple baseline settings, we get a much better picture of what's happening, and it allows us to infer, a functional relationship. So why are multiple baseline designs good? One, they allow us to demonstrate a functional relationship. Remember, that's a goal of research, is to demonstrate a sort of causal or functional relationship. Because treatment is replicated across 2 or more baselines, and because behavior changes only when treatment is implemented, right? So we can demonstrate a functional relationship because treatment is replicated across 2 or more baselines, right? We have the replication aspect that we talked about, and behavior changes only when treatment is implemented. That allows us to rule out some extraneous explanations, right? So multiple baseline designs give us that kind of. Okay, up next we're talking about alternating treatment designs. This is when baseline and treatment, or 2 different treatments, occur on alternating days or sessions. So the general logic behind this sort of design is that any extraneous variables would have a similar effect on both conditions, right? If something's going on that's influencing the subject, it should have a similar effect on both conditions. So the extraneous variable could not be the cause of any differences between those 2 conditions. So in this graph here, we're depicting the frequency of aggressive behaviors across time, days, and in white we have violent cartoons, and in black we have no cartoons, and we're plotting the frequency of aggressive behavior. So you can see here in white we have presentation of violent cartoons, and in black we have no cartoons, and those alternate, right? So day 1, day 2, day 3, day 4, day 5, day 6, and so on. So they alternate back and forth. We have a data point for each day, and this allows us to sort of try to rule out any extraneous variables in that way, because we're alternating back and forth. Because we would expect that if there is something on the outside that's having an effect, it is having a uniform effect on both conditions. Okay, just to say this again in kind of a different way, we can demonstrate a functional relationship between the IV or IVs and our DV when the data are separated between the two conditions, right? If we see a separation between the two conditions. We can also call this a multi-element design. There are multiple elements. And as I've said already, this is valuable because any extraneous variables should have a similar effect on both conditions because we're alternating rapidly. So an extraneous variable should not be the cause of any differences between our conditions. So it gives us a little bit of extra confidence. Okay, the last type of design we're going to talk about is the changing criterion design. This consists, like AB, of a baseline and treatment phase. But unlike a simple AB design, there are multiple performance criteria or goals in the treatment phase. So we set multiple shifting goals or criteria, multiple or changing criteria design during the treatment phase. And we can claim a functional relationship when the behavior matches the performance criteria, right? Because each time the performance criteria changes, if the behavior also shifts to accommodate that change, that is a functional relationship, right? So it gives us enough power to make a claim like that. So in this example, we have total caffeine intake. The goal of this design is to reduce the subject's caffeine intake. So the dotted line in each segment represents the average amount of caffeine consumption for that phase. The solid horizontal lines represent the criteria or the goal that is present in that particular phase. And the individual data points are the amount of milligrams of caffeine that are consumed per day, and this is tracked over days. So basically in this experiment, the participants are incentivized. If they drink less caffeine per day than the goal, then they are incentivized, they get some money. But if they drink more, then they lose money. So we want to see if that works. We set this goal. The participant here adjusts their caffeine consumption to be below the goal. The goal shifts lower and lower and lower, and each time the caffeine consumption drops with that, demonstrating a functional relationship. Okay, that's it for graphing behavior and measuring change, just 2 parts this time. Next time we're on to discussing reinforcement.